So I thought it'd be fun to build an N100 rack mount server that you could use, say, as an OPNsense box, or say a lightweight virtualization server, or if you just want a little lightweight rack mount desktop or whatever you want to remote into. So you could use it for various purposes, but the thing that you get with building your own do-it-yourself version of the N100 system is you can customize the hardware that you have in it, and you can maybe repurpose it later. And N100 is a pretty capable low power, system that's great for using it for OPNsense. You can do a little bit of probably IDS, IPS on it, but you got to keep in mind the limits and expectations of the performance on those kinds of boxes. But the power consumption is always a good selling point for these. So full disclosure, I bought all the hardware or own some of the parts already, and I just wanted to do this project because even though I have a different goal in mind than what this video is going to be demonstrating, I thought it'd be fun to demonstrate that you can build your own router and still be energy efficient. In this video, I'm going to focus on setting up the Rackmount server with OPNsense on it first to show you this project, then how you can get that set up, and then in a follow-up video, I'm going to do an updated OPNsense build guide for a full network using this Rackmount server, but you can use any hardware course to follow along. And I'm going to be using my Grandstream switch and APs that I got, hopefully to show you just different examples of how to set up networks in different ways. So I hope you'll stick around for that. And so let's get started. But on this table is all the hardware I'm going to be using for this project. I'm going to start with the 2U RackChoice chassis that I purchased. The reason that I chose this chassis is I'm going to take this panel off. I already took the, there we go, it's kind of stuck there. I don't know if you can see it in the video, but there is a plate here on the top. You can mount 2 hard drives on the top. And you can also mount some underneath here as well, and you have a 5 1/4 inch bay. But this plate here is really important because a lot of these low-end budget-friendly cases have a cage, like 2 cages here, and you have to put the hard drives down underneath them, but you have to mount them in there. So you have to take this whole bracket out, mount the hard drives in, and put the bracket back in, and screw it down in there, which is hard to reach the screws. And even with a longer screwdriver, if you drop a screw down in there, it's kind of tricky to screw it back in. That's how my other 2U case is that I have. And so every time I need to swap out hard drives, which I do on a periodic basis if I'm upgrading or just moving hardware around or repurposing the hardware, it was such a pain to do that. But this has a nice place that you can mount pretty easily on top. You can just take this top plate off, and you just screw the hard drives to the plate and then mount the plate back on. And not only that, this was $10 to $15 cheaper than the other RackChoice cases. So I was like, it's cheaper and it has a better hard drive mounting. Other than that, this is just a standard, it holds a micro ATX motherboard, which is what we're going to be using. And so I have a EVGA, just a 600 watt power supply. I happen to have this one already. You definitely don't need a power supply with this much wattage for N100 system. So you can save money on a power supply if you can get a lower wattage one. I'm going to be using the ASRock N100M. Okay, so I want to make sure I got that right because I'm looking at it backwards there. N100M. All right, so here is the ASRock N100M motherboard, and it has the soldered on N100 CPU with a heatsink on it. It doesn't come with a fan. You could, in theory, run this as a fanless system. And what I've found is, since these chassis usually have fans in the front, I don't know about this one actually. It might not have any. You could, yeah, it actually has 2 in the front, so that's great. So there's 2 fans in the front, and then you have the power supply, which also is exhausting some air out the top of this case and out the back. And so you have a little bit of airflow in here. So I found that with my other N100 that I've already built that I don't seem to need a CPU cooler for this processor because it runs cool enough because it's low enough wattage. All right. And then I have just a 16 gig DDR4. It's, let's see, what is it? 3200 megahertz. So that's what I got for this system. This is the fastest speed RAM that will run on this motherboard. The interesting thing about the N100 is, for the mini-PCs that you'll see out there, some of them have DDR4 RAM and some of them have DDR5. So this architecture supports either memory specification. So this motherboard only does DDR4, so you don't have quite as much memory performance perhaps as DDR5, but it's still plenty plenty fast, I think, for this purpose, because there's probably going to be other bottlenecks you're going to encounter, probably more so than the memory bottlenecks you could experience. All right, so this is a 2.5 gigabit Ethernet interface, and I already owned this from a couple years ago when I didn't have anything but 1 gigabit Ethernet interfaces on my network. So I needed a couple 2.5 gig interfaces so I can test some stuff out. So I'm going to throw it in this system because this motherboard line comes with a gigabit connection, a single one. So unlike other mini-PCs that have like 4 2.5 gig interfaces, this doesn't have any, but it does have 2 PCIe slots, which is interesting because one is a PCI 3x2 and one's a PCI 3x1 lane. So you got one with 2 lanes and one with 1 lane. And the one that has 2 lanes is actually about a 16 slot size. I like this motherboard because ASRock has another motherboard that only has, it's an ITX one motherboard that only has 1 PCI by 1 slot. But this has 2 PCI slots, which is pretty interesting to me because you can do, say, faster speed interfaces on this, or have multiple interfaces besides just like a single one if you want, which would be perfect for our OPNsense build. Another thing that's interesting that I bought, and I'm going to try this in a future video, but I just wanted to show it in this video as a little preview. But I bought a 5 gigabit Ethernet card, and I saw this on Serve the Home said that IOCrest makes a 5 gigabit PCI card. It's really difficult, it seems like, to find a 5 gigabit Ethernet interface because they're all 2.5 gig or 10 gig, right? So this one's interesting because most of the time when you see a 5 gigabit Ethernet interface, it's a USB dongle or something like that. And so I want to test this in a future video, and I'm going to use an SFP, the RJ45 module, to see if I can get 5 gigabit on a 10 gigabit SFP plus interface. So that'll be interesting. I think that'll work out. PCIe by 1 slot is 1 gigabyte per second, which is 8 gigabits per second. And there's a little bit of overhead in PCIe bandwidth plus overhead on the network interface. So I'm hoping, even though this supports 8 gigabits for this 1 slot here, the PCI by 1, this should get the full 5 gigabit throughput. So now PCIe 3.0 by 2 supports 2 gigabytes per second, which is 16 gigabits per second in theoretical max. So I got a 10 gigabit SFP plus card here to put in this slot so I can get full 10 gigabits. You could get a dual, this is not a dual 10 gigabit. You could get a dual 10 gigabit interface, but just keep in mind that you won't be able to get 20 gigabits of throughput through it because you're limited by this PCIe 3x2. With this card, I bought a Mellanox ConnectX-3 to work with this motherboard so I could take full advantage of 10 gigabits. So the great thing about doing it yourself is you have different options to configure the interfaces how you want. You could do 4 2.5 gig interfaces with no bottlenecks on the slot with 2 lanes, or you could do dual 2.5 gig on the PCIe by 1 slot, and so you could still get up to 5 gigabits of bandwidth between 2 ports on that slot, and you could still have a 10 gig slot. So you could have 1 10 gig interface, or 2 2.5 gig interfaces, or 4 2.5 gig interfaces. You could even get a dual 10 gig interface to put in there, just keeping in mind that maybe you won't be saturating both interfaces at the same time. So you could still get, even if you are saturating both, you could still get, maybe 14 to 15 gigabits per second, which is still better than 10, right? So you could still get a little beyond 10 gigabits aggregate throughput between 2 different interfaces. One thing I forgot to include is the SATA SSD. It's just a basic 256 gig. It's an old, SATA SSD that I had laying around not using it. So I'm going to use that for this build. I don't have it on the table, but you'll see it in the completed build. I'll have it mounted on top here. So I wanted to mention a couple of challenges I had with this project in case you encounter something similar, but there were some things I didn't expect and didn't think about when I went into it, and it's just kind of funny when you have an idea in your head and you go to execute it and you're like, oh, I didn't think of this or that. So this is one of those cases. So the first issue I had was when I booted it up, there's LED diagnostic lights on the N100M motherboard from ASRock, and it would always stop on the DRAM which is your dynamic random access memory light, and it would stop on that and then just shut off. And it would do that every time I turn it on. It would just stop on that. So I thought maybe I had incompatible RAM, and I was like, this works on other systems I've had. I don't know why. It's just standard DDR4 RAM. And so I bought more RAM, thinking maybe it's real picky about memory, because sometimes motherboards are. So I bought new RAM, stuck it in there, and it still did the same thing. I powered on, it shut off. So I was like, now that's really weird. And the only thing I could think of to try, besides the fact that I kind of doubted that the motherboard was bad, usually doesn't happen real often. You get new hardware, but that's always a possibility. But then I thought, I have a really old power supply that I was just reusing. I just kept passing it down from system to system, and it's probably like from 2010 or 11. It's still an ATX compatible power supply. It's worked for all of my systems that I've used over the years, over the last decade or so. I'm like, it's probably good if I retired that. And I ended up having an extra power supply just laying around. And so I stuck that in there, and then it booted up. So it wasn't a RAM issue. Another issue that I encountered, that after I got everything fired up and I had a couple extra 10 gigabit SFP plus NICs, stuck them in there. And I was only getting like 6 gigabits per second. So I was like, 6 gigabits per second. I know this motherboard with the PCIe 3.0x2 should be able to be capable, in theory, up to 16 gigabits. So I was like, there's something weird going on here. And then I realized I was using the Intel X520 chipset, which is only PCI 2.0. So, and PCI 2.0 has half the bandwidth, which means I can only get 8 gigabits per second, maximum, theoretical max, on a 1 gigabyte per second, PCIe by 2 for 2.0, right? 2 lanes. So I was like, I needed one with a 3.0 PCIe 3.0. I need a NIC with that, a 10 gig NIC for this to work. And so I realized that the Mellanox ConnectX-3 is in about the same price range as the old, Intel X520, because they're older NICs, both of those. I realized it's a PCIe 3.0 card, which is awesome. I put that in there, and I can get full 10 gigabit throughput for speed testing. It all worked out great in the end. When you first boot up your system, you might be taken to your BIOS screen if your hard drive is empty or doesn't recognize any disks or whatever. But we want to go in here anyway, because you notice the 16 gigs of crucial RAM that I have. We'll need to tweak a few settings. This is one of them. It's defaulting to 2666 for the speed, and it can support up to 3200 megahertz. So we want to take full advantage of the memory bandwidth that we have available to us. So if we go to advanced mode, I like to go there because you can get all the settings exposed, because we're advanced users, right? If you're following this channel. So let's go to OC Tweaker, and you'll see DRAM configuration is an option here. So let's go to here. All right, so now you'll see the DRAM frequency right here, and it's defaulting to that speed. So let's go to where it says auto. We don't want to default it to that speed. We want to go scroll all the way down. This scroll wheel doesn't work on here, so I just have to drag that bar. We'll click on DDR4 3200. That's the max speed that this motherboard supports. So once we set that to that speed, we need to reboot it to take full advantage of that. So let's exit and make sure we save changes, because I don't want to boot directly from, since we have settings we need to save, I don't want to directly boot into this disk. So let's go ahead and hit save, and we'll just do this, and we'll reboot it and see if it will take effect. All right, so we're back into our BIOS, and it says our crucial 16 gigs of RAM is at 3200 megahertz, which is great. So that means we got our RAM set that way. I also, you notice in the boot priority over here, I got my thumb drive plugged in with OPNsense, because we're going to install that. Since I just went ahead, since I had to shut the system anyway, I just plugged it in. All right, so now we're going to be booting up the OPNsense installer. As you can see, it's loading right now. One thing I like about the Rackmount case I forgot to mention earlier, it has a USB 3.0 ports on the front instead of 2.0, which is one other consideration besides having the nice hard drive trays on the top. It's easy to get to. So I'm hoping that'll make the installers a lot quicker when I'm trying to install something on that system. And one other thing I need to mention is since we have a Mellanox ConnectX-3 NIC in there, it's probably not going to detect it on the first boot of OPNsense. So that's something we can enable that module later. But it's kind of interesting because here it looks like it's initializing the driver, but then it doesn't actually work. So until we probably have to enable it. So we'll see how that goes when we get started here. So we're going to do manual interface assignments. We'll do no. Configure VNs, no, nope. And so I'm going to use IGC 0 for the WAN, which is the 2.5 gig interface, because most people will have, in general, going to have 2 gigabits or less internet. There's a lot of people that do have greater than that. So you can always use your 10 gigabit card, but we just need to put something here for now. We can reassign the interfaces later. So IGC 0, if I could spell right, IGC 0 for WAN, because that's our 2.5 gig interface. And then this motherboard has a Realtek interface installed. I'm only going to use that maybe just for management purposes. It should still work, but since we're just going to use that just to log in for OPNsense, I don't see any harm in using it for that purpose. And then we'll have a 10 gig NIC that we have in there for our LAN interfaces. Okay, so we'll just do RE0 for the motherboard one. I like using the motherboard interfaces as management interfaces. So we're just going to enter, and we will proceed. All right, so now we can run the installer. So we can just type installer, installer, and then OPNsense is the password. We're gonna default key map, we'll use that, and we'll do ZFS. And we're gonna do Stripe because we only have one drive, and we only have one drive in our system, so hit spacebar and we enter. And yes, we want to destroy everything, and it's going to continue with the installation process. All right, so now it is complete, so we can do the root password. We can change it. All right, so let's do that. All right, now we can just hit complete install and reboot. All right, so you just need to take out your thumb drive at this point in time. All right, the system is rebooting. And this is booting from the hard drive now instead of the thumb drive because I pulled it out, and we'll see what we get here. All right, so now the system is booted up and we can log into the OPNsense web interface. Once we connect a system to the LAN interface, I'm going to connect everything directly to it. I always like setting up OPNsense boxes in general, disconnected from the network, and that way I can get it set up, make sure everything is not interfering with my current network. So now I'm on another system I'm using to manage OPNsense, and I'm plugged straight into the LAN interface, which is the interface is built onto the motherboard, which is a Realtek interface. And we just type the root password and the password you changed it to, and we'll log in. I already clicked out of the wizard already, so that way I already logged in, so that way you can just see the dashboard right away. And you can see this is our OPNsense build. I tried to zoom in a little bit, so maybe zoom out one more just so you could see the interface a little bit better. So you'll notice when we go over to interfaces and we go to assignments, that we don't have any extra interfaces, and we have a 10 gig interface that's not listed here. So to be able to see that interface, we need to go to System, Settings, Tunables, and then in the Tunable section, we need to go to Add at the top here. So in the top here, we need to type in MLX4EN_load. And you can type whatever you want for a description, but I'm just leave it blank for this illustration, and we just enter yes for the value. And this is going to enable the Mellanox 4EN driver, so MLX4EN. So this will allow us to see the 10 gig interface. So apply changes, and we need to go to power, and we'll just reboot this sucker. So we'll just go reboot this system. All right, so then once the system reboots back up, we just sign back in again. All right, then we'll just go over to interfaces, and we'll go to assignments and see if there's any new interfaces in here. And you see the MLX EN0 is our 10 gig interface. So now it shows up. Now that we have this set up, I'm going to be using this OPNsense installation to do a video on with some Grandstream hardware that I got And I'm going to do an updated guide on OPNsense, since there's been a lot of changes since I first did the guide 2 years ago, and that this dashboard is one of the bigger changes that you will notice visually. But there might be some other features and stuff, and the interfaces have changed and features have changed a little bit in the various plugins and different settings. And so I want to do an updated guide on that so that you can see how to configure the latest versions of OPNsense with different hardware, and just give you different examples of how to set different networks. So I hope you enjoyed this project, because I thought it was a fun project for me. I had different goals in mind in this video, but I thought I could use it as an example, and I think it works out great. For those who want to rack mount everything, you can build your own rack mount OPNsense or PFSense box. If you want to have the flexibility to change network interfaces, or upgrade different things and use them for different purposes later, you can repurpose this. So it's just fun to build these types of projects and to show you what you can do. Until next time, I'll see you guys later.